Two ways to hide the mess. One lets you work with multiple superpowers, the other brings structure. Which would you choose? When you use a microwave, you don't care how it works inside. You just press buttons. That's abstraction. Yo, welcome back. It's your chill Java coach over here. Today, we're learning about abstraction, the act of showing only what matters and hiding the complex stuff. What is abstraction? Well, let's see the question. What is abstraction? Abstraction means hiding implementation details, showing only essential features to the user. Achieved in Java using abstract classes and interfaces. Now, when you fly a plane, the only thing you see in the plane is the yoke and the controls. You don't see how the gear is turned. You don't see how the engine rolls. You don't see any other thing. You don't see the pistons pushing, but you only see how to control the plane. When you use your phone, you don't see the electrical signals being sent from your body to the screen, to the capacitive layer on top of your screen that helps detect where your finger is. All you see is your response from the device. That is abstraction. When you use a microwave, that is abstraction. So let's see an example using abstract classes. Now we have a class still on the animal class where animal makes a sound. Then next we have the abstract class animal. Then, sorry, there's a mistake there. I typed in a double A. Okay, so let us use our IntelliJ IDE to see this better. Okay, so for abstraction, we talked about that abstraction, or we said abstraction helps us to hide implementation details and show only essential features to the user. And we achieve abstraction in Java using abstract classes and interfaces. So now let's go in detail what abstraction means. Like to a layman, how can you explain abstraction? Well, to explain abstraction, sorry, let us think of it using our smartphone. So imagine you're using your smartphone right now. Just look at your smartphone. You know how to make calls. You know how to send messages, take pictures, and use the various apps in your phone. However, you don't need to understand the complex internal workings of the phone, like how the processor handles instruction, how the screen displays images at a pixel level, or the intricate detail of the operating system. Now, some phones use OLED, some use tandem OLED, some screens have pixels on top of another pixel. Some have 4K display on 4K display. So you don't need to know what those things do or what the LED or anything the in your phone do. You just need to know how to use the apps you are seeing. So abstraction in programming, including Java, is like using your smartphone without needing to know all the nitty-gritty details inside. It focuses on showing you the essential information and hiding the complex implementation details. It lets you work with a simplified view of something. Now, here's another way to think about it. When you see the interface, which is when you see an app, you see buttons, menus, and displays, right? This is the abstracted view, the essential part you interact with, the icons, the buttons. What's the hidden part? It is the implementation. Behind those buttons and displays is a lot of complex code that makes everything work. You don't need to see or understand this to use the app efficiently. Now imagine you're using the OPay app. Now the OPay is one of the best apps in fintech. If you're using OPay, this is not a sponsored video by the way. So if you're using OPay and you are trying to transfer, do you care how OPay subtract your balance and increases the next person's balance you're trying to transfer to, you don't care. All you care about is pay loads, you put your pin, then it gives you the receipt which you send to the other person or the person on the other end. That is what you are concerned about. So that is abstraction for you. The user only gets to see the UI, but the implementation is hidden from the user. So in Java, abstraction is often achieved using abstract classes and methods. Now, we're going to see examples of the abstraction or abstraction in Java. So let's in our IntelliJ, let's create an abstract class called, okay, let's use the word animal, right? So notice my file is called abstraction. I'm able to create a class called animal because it is not public. Immediately it becomes public, I get an error because yeah, it should be animal.java. So whenever your folder, your file name is different, please do not use the public keyword in creating a class. So now we can now say that abstract, uh, okay, so we want to call something. So we're going to create a method. Now this method, we're going to call this method sound. All right. So this method, we're going to say it should do something like, oh, sorry. Okay, so you should print animal is no, let's not do anything with the method for now. Let's just declare the method, okay? Let's just declare the method. Right. So using the abstract keyword, we just declare the method. Now we want to say something void eats, then we say this, or let's say animal is eating. Animal is eating. So next up is to say in our another class, we want to create class of cats and we want to extend the animal class and want to say void. We want to create another method and we want to do animal is okay for cats. Let's just say meow. All right. All right. So let's do something now. In our class of main, public class of okay, let's leave it as abstraction. Then we want to say public static void, and we want to say a object of animal, a dot sound and a dot eat. So what have we done now? So this is for, let's put a bit of comment here, a little comment method and meow, and this is for animals eating. Right. So now in this code, sound is abstract. How do we know? We use this keyword here, abstract. Right. So sound is abstract. It is not. Because if you look, the it is not having this abstract keyword. Now, we hide the sound logic from the parent. What do I mean? This is the sound here, but the logic is not showing. This is the parent. But the logic of the sound, how is the sound come, or how do we make the sound? It's not being told to the parent. So this is the parent. All right. So animal covers all the animal in the animal in your planet or whatever. So this is the entire wrapping block. Now we say the animal makes a sound, but you can see that how the method of the sound is not declared here. If you declare the method, there will be an error because you're not supposed to declare abstract method. You're just to leave them so that the user does not know how it works. Now, later on, we can now declare the how who makes the sound? Now we say cat. We're extending the animal class. This is what we call inheritance. Okay, so we're extending it, and we're calling the we're calling the okay, sorry, we're creating a new method of sound. And now, since we made it abstract to the first class, we can now declare it in this new class what sound, we can now define what the method does, which is this meow. But now, if you notice, the it method is just there, it's plain inside the parent class. So the it is not abstracted. So this can help us to write codes. Maybe if we're writing something in a real world now, we're writing a code for a bank account again or an ATM. So we can be able to set the withdraw function as abstract, the deposit button function as abstract. So when the user calls them, in another class, we can define the method for withdrawal. And in another class, we can define the method for deposit. So what the user sees is just the abstract buttons for each and every one of this. So this could be used as a toy, that the child can only see the button for sound, and he doesn't know how the sound is being made. So this is just an example of abstraction. So let's go back to the theory slides. Okay, so if we're using if we say why use abstraction as another question, why should we use abstraction? Now note that abstraction forces subclasses to implement important stuff. Abstraction hides unnecessary complexity. And third, abstraction makes code more modular and readable. So initial one is very important. It forces subclasses to implement important stuff so it doesn't get skipped. Number two, it hides unnecessary complexity. And number three, it makes code more modular and readable. E.g., when you read that code, you saw that this was abstract, so you already know that this is hidden from the user. Now, take note, you can't create objects from an abstract class directly. So since it's hidden, you can't access it directly. So yeah, abstraction equals just pressing the button. Don't worry about the wires. Next, I'll do a face-off. Interface versus abstract classes. Which would you choose? Or which should you use and when? Like, sub and drop a comment saying hashtag clean code in the comment section if you get the vibe now. So, see you in the next